Today's lesson is called Domain and Range Day 2. You're going to start with an opening exercise that says for each relation, determine the domain and range, write in proper notation. So a quick reminder, domain is your set of all x's. Remember, range is your set of y's. When we say proper notation, we are referring to both the inequality and interval. You are going to review domain and range for graphs, table of values, list of coordinates, and mapping diagram. At this time, you can pause the video, try the opening exercise on your own, and then resume to go over the answers. Okay, now that you had a chance to try it on your own, let's go over the answers. For the graph, anytime you have a graph now that is continuous, remember you want to put infinity symbols next to the arrows to show where it's going on forever. That will help us when we go to do the pinching. So just as a little bit of a flashback for domain, we're trying to pinch from the left side. When we do that, we bump into the graph at an infinity symbol, which is not okay. The same thing happens when we try to pinch that sticky note or slide that sticky note in from the right, so it's not okay. And that's why it's all real numbers, that weird capital R, and then remember from negative infinity to positive infinity. When we try to do the same thing for the range, we can slide up from the bottom and we bump into the graph at -3, but when we try to come from the top, we bump into infinity symbols, which is not okay. So for the range, we are y is greater than or equal -3. That means -3 is our lowest included, so a closed bracket, up to positive infinity, which is open. For a table of values for the domain, you want to list all the x values. Do not list any numbers twice. So that's 0, 2, 8, and 18. For the range, you want to list the y values. So that's -3, -2, -1, 0, 1, 2, and 3. Don't forget your curly brackets for set notation. For your list of coordinates, your domain are your x's. These actually have all the same x value of 4, so you're just going to list 4 by itself as the domain. And then your range is 0, 1, 2, 3, 4, and 5. And then for your mapping diagram, you can think of this kind of in two different ways. If this was representative of a larger problem, and they would kind of explain this to you in the directions, you might list the domain as the months of the year. They're only showing you a sample, but essentially that's what they're doing, is showing you the months of the year. And on the right, they're showing you the number of days in that month. If you want to be specific to only what you see in front of you, that would be January, February, March, April as the domain, and 28, 29, 30, and 31 as the range. So now we want to move on and take a look at some of the things we did not talk about on day 1. It says we also need to be able to find the domain and range for the following. So we want to add in today what to do when you're faced with an equation and what to do in an application situation. The directions are still the same for each relation, determine the domain and range, and write in proper notation. So let's start with equation. We have to be able to find the domain and range of an equation. So there are a couple ways you can do this, and then on the right-hand side, you're going to see two big hints that we have for each of these categories. So for the domain, remember domain is your x values. One way to look at this is to look and see that x is actually underneath a square root. We know from previous lessons and things we've learned in the past that we cannot have a negative number underneath the square root. So keeping that in mind, I want to think to myself, what is the smallest number I can put there that's going to make sure I avoid a negative? And that number would be 7. If I were to put 7 in there, 7 take away 7 is 0, and the square root of 0 is 0. So what we're going to write here is that any number smaller than 7 would make the square root of a negative number, and that's a no-no. Okay, So that's important. So one way to figure that out is by looking at the structure of the equation. Knowing that information helps me decide that it has to be 7 or bigger in order to avoid negatives. So that would tell me that x is greater than or equal to 7 in inequality. And then in interval notation, that means 7 is our smallest, and we're going to go on forever up, positive, so positive infinity, not included. The 7 is included, so close bracket. Now, once you know the domain, you would just use the domain to find the range. So here, I'm going to draw an arrow to the y, and I'm going to say use domain to find range. So what I mean by this is we already know 7 is the smallest the domain can be, so let's plug in 7. So we'd have y is equal to the square root of 7 minus 7, which is equal to the square root of 0, which is equal to 0. So now I know the smallest number in my range is 0, and anything else is going to be up from there. So y is greater than or equal to 0, which means 0 is our lowest, and we're going towards infinity. Infinity is never included, so open bracket. The 0 is included, so closed bracket. Now, this can sometimes be challenging, especially when you run into equations that you don't truly understand the nature of. So the best hint that we can give is actually just to use your graphing calculator, and it'll tell you the answer. So let me show you how you can put this equation into your graphing calculator and look at the table of values or the graph to help you do this. Now, looking at the graphing calculator, we're going to type in our equation in y1. So we have second x squared, which will get us to the square root button. And then we're going to type in x using the variable key to the right of alpha, subtract from our gray operation keys on the right, and then 7, and hit enter. Then we can hit zoom and 6 and get a picture of the graph. So you can kind of see it's only showing us positive y values, which goes inside with our y is greater than or equal to 0 that we already saw. And it's showing that it's going to keep going over to the right, but starting at 7, because you can see the scale at the top, 7.5, it's starting at 7. But what I think is even better is looking at the table. So hit second graph and look at your table. You see all the error symbols that I'm getting. I'm going to keep going down and down until I finally don't run into that error message. So you can see across from 6 is error, but as soon as I get an x value of 7, I get 0. Then 8, I get 1, and so on. So that's telling me right there that my x's start at 7 and my y's start at 0. So let's get that into our notes so that we have it as a reference. So we're just going to take a few rows from the table. We're going to look at x and y1. And we had 6 with an error. So we know that doesn't count. Even think about it. 6 minus 7 would be negative 1. Can't have the square root of a negative. But then we run into 7 with 0. We run into 8 with 1. And you can see from this point and up, we are okay. So that would help us see that x has to be greater than or equal to 7 and y has to be greater than or equal to 0. And we can use that instead of the reasoning with the equation. Now, when it comes to the application, here's an example. A relationship that predicts the number of household online devices in terms of the number of people in the household. So the first thing you have to do is figure out which one's the domain and which one's the range. The way this is wording, it's saying it predicts the number of household online devices in terms of the number of people. So that would mean you need to know the number of people to know the number of devices. So that tells us that the number of people in the household is actually the domain, and that the number of household online devices is actually the range. So here, there's a question about the domain specifically. It says, which domain would be the most appropriate to use in this situation? So our major hint for this is you are going to pick these types of answers from your real number system. So you're going to choose a subset of the real number system in order to answer this question. So thinking about it in terms of real life, we're talking about people. So if we're thinking about the type of numbers we're allowed to use, that could be 0 and up, but we don't want any decimals or fractions because you're not going to have a fractional person. So over here, I'm going to put no partial people. So what that means for us is we want no decimals or fractions. And obviously no negatives. So thinking in terms of real life, what kind of numbers are from 0 and up, right? No negatives, and no decimals or no fractions. That would be whole numbers. And that concludes your lesson on domain and range, day 2.